In the last video, we learned how to calculate the slope of a line using a graph. But what if you're given 2 points and no graph? How can you calculate the slope? Well, in this lesson, I'm going to show you exactly how to do this. Let's start with our slope formula. In the last lesson, we learned that slope is equal to rise over run. If you haven't watched that lesson yet, I recommend going back and watching it first. Today we're going to take this idea of rise over run one step further. Here I have a line with 2 points. Remember that every point on a graph has an x and a y coordinate. So I'm going to label the 2 points like this. Point 1, x1, y1, and point 2, x2, y2. Let's start by discussing the rise first. So if you remember, the rise is the vertical change, so up and down, between these 2 points. On a graph, vertical movement is represented by the y-axis or the y values. So we could say that the rise is the change in y. The run is the horizontal change, so how far left or right between the 2 points. Horizontal movement on a graph is represented by the x-axis or our x values. So we could say that the run is the change in x. This means that we could write our formula like this. Slope is equal to change in y over change in x. And when I say change, I'm simply talking about the difference between the 2 coordinates. So we could also write our formula like this. y2 subtract y1 over x2 subtract x1. And this is the formula that we'll be using throughout this lesson, and it's definitely one that you'll need to memorize. Let's start with a simple example using 2 positive coordinates. The first thing that we need to do is label which point is point 1 and which one is point 2. I'm going to label 1, 3 as point 1 and 7, 9 as point 2. You could have labeled them in the opposite way and you would still get the same answer. Next, we need to set up our formula. On our numerator, we have 9 subtract 3, and on our denominator, our x values, 7 subtract 1. Next, we need to do the subtraction in the numerator. So 9 subtract 3 is 6, and subtract in the denominator, 7 subtract 1 is also 6. Finally, we want to simplify our answer, and 6 divided by 6 is just 1. If you remember, when we're dealing with slope, we always want to leave our answer as a fraction because it's easy to see the rise over run. We don't want to use any decimals in our answer. However, in this case, because 6 divided by 6 gives us a whole number, you can in fact just say that the slope is 1. You could also say that the slope is 1 over 1 if you'd like to leave it as fraction form, and that is completely correct as well. Let's try a second example that's a little bit more difficult with negative coordinates. We're going to follow the same 4 steps on the left side of the screen. So let's label our points. Again, I'm going to label the first point as -7, -8, and our second point as -1, -5. Let's set up our formula. So on the numerator, we have -5 subtract -8. Remember that if you're subtracting a negative number, we always put the negative number in brackets. It just keeps the equation much cleaner. On our denominator, we have -1 subtract -7. Remember that when you subtract a negative number, it's the same as addition. So the numerator can be written as -5 plus 8, and our denominator, -1 plus 7. -5 plus 8 gives us 3, and -1 plus 7 gives us 6. And finally, if we simplify this fraction, we get a slope of 1 over 2. Okay, let's do an example with fractions. Again, we want to label our points first and set up our formula. On the numerator, we have 1 subtract 2/3, and on our denominator, we have 1/2 subtract 1/3. At this point, we have fractions within fractions, which can make the calculation a little bit more complicated. There are a few ways that you can deal with this, but the simplest way is just to get rid of all your fractions. Make this question simpler. The way to do this is to find the common multiple of all the denominators. So if you look at our points, I've circled all of the denominators. In the first coordinate, we have a denominator of 3, and you only need to circle that once. In the second coordinate, we have a denominator of 2. If you'd like, you could write out a list of all of the multiples of 3 and all of the multiples of 2 and look for a common multiple between those numbers. But of course, if you're doing an exam or just homework, this can take a lot of extra time. The simplest way to find a common multiple is just to multiply these numbers together. So 3 times 2 will give us 6. Now we can use the common multiple to get rid of the fractions. What we want to do is multiply the numerator and the denominator by 6. Let's start with the numerator. 6 times 1 will give us 6. 6 times 2 gives us 12, divided by 3 gives us 4. And our denominator, 6 times 1 gives us 6, divided by 2 gives us 3. 6 times 1 gives us 6, divided by 3 gives us 2. And now we just have a simple equation like the other two previous examples. So 6 subtract 4 gives us 2, and 3 subtract 2 gives us 1, or just simply a slope of 2. Let's try another example. Before we do any math, can you spot anything about these 2 points? Notice that the y-coordinate is the same for both of these points. That means that we will have no vertical change. So we already know, before any math is done, that this is going to be a horizontal line. And if you remember from the last lesson, horizontal lines have a slope of 0. So our formula, once we've simplified, should give us 0. Let's try it out. Let's label our points and set up our formula. On the numerator, we have 2 subtract 2, and our denominator, 4 subtract -3. And again, remember that when you subtract a negative, it's the same as a positive. Or excuse me, it's the same as addition. So we can put 4 plus 3 in our denominator. 2 subtract 2 is 0, and 4 plus 3 is 7. 0 divided by anything in math is just 0. We can also double check that we do in fact have a horizontal line by graphing these 2 points. -3, 2, and 0.42. If we draw a line connecting the points, you'll see that we do in fact have a horizontal line. Let's do a final example. Do you notice anything about these 2 points? The x-coordinate is the same here for both points. That means that there'll be no horizontal change. Before any math is done, we already know that this will be a vertical line. And if you recall from the last lesson, vertical lines have a slope that's undefined. Let's try it out. Label our points and set up our formula. In the numerator, we have -1 subtract 3, and in our denominator, 1 subtract 1. -1 subtract 3 gives us -4, and 1 subtract 1 gives us 0. And remember that anything divided by 0 is undefined. Let's check by plotting our points. 0.13 and 0.1, -1. If we draw a line to connect these points, we do in fact have a vertical line. Let's do a quick review. Remember that slope is the change in y divided by the change in x. We could also say that slope is the difference in the y coordinates divided by the difference in the x coordinates. A horizontal line will have a slope of 0, and points on a horizontal line have the same y coordinate. A vertical line has an undefined slope, and points on a vertical line have the same x coordinate.